Dear viewers, in India, some states are affected by power cuts. There are a number of solutions to escape from power cut. You can use generators, solar panels like that. UPS inverter they are using. Cost of the inverter is costing around 20,000 rupees with battery. Until basic solar panel may cost 6,000 rupees. And with the inverter and battery it may cost around 15,000 rupees. Not all the people can spend this money. For mobile charging and laptop, you use 2,000 rupees basic UPS. So that it may be charged within 15 minutes or 20 minutes. And also you can use it for Wi-Fi so that you can use your mobile 24 hours. But this is not recording mobile or laptop. This is recording our daily life need, which is a fan and light. During night, most of the people in villages, rural areas, they may face power cuts. In urban areas also they may face power cuts. But everybody will be affected by sweat and mosquito bites. That's why I am giving you a simple solution. The cost of the product is around 2,000 rupees. Just a DC battery charger. With the help of this charger, you can run a small fan and DC bulb. Charger basic circuit is transformer, rectifier, and then filter, and then a buck converter. Some 13.5 to 14.5 volt will go to the battery. From the battery, we are going to give a connection to a car DC fan and a DC bulb. In case any power cut, you can make use of that DC fan or DC bulb. In nights, you will be relieved from the mosquito bites and also that sweat. I will give you the specification in the description or in the video itself. You just follow that to make the device. I will tag the product in the descriptions, which I have bought from Flipkart and Amazon. You can just buy it from them. The circuit is a basic circuit and doesn't have a short circuit protection and also battery cutoff. For that, if possible, I will publish one more video in the YouTube by the next year. This image represents the connection diagram. The circuit diagram is at the end of this video. This is easy way to learn and troubleshoot the circuit in case any problem in the connections you have given. This is 12 3 ampere step-down transformer. The input voltage is 230 volt. I am checking power supply voltage. The voltage is 197. The voltage is lesser than 230. That's why the output DC voltage from the rectifier might be less than 12 volt. The input 196 volt is given to the transformer. Now we are checking the input voltage to the transformer. It is also 196. By checking this, we can find out the voltage drops. The output voltage is given to the input of the bridge rectifier. The output of the transformer is 21 volt. We can also check the input of the bridge rectifier. That is also 21 volt. The rectifier output is given to the filter circuit input. There will be a spark across the pi filter. That's why I am not measuring that. Filter circuit reduces the AC ripples. The output of the filter circuit is given to the buck converter input. Filter circuit output or buck converter input is 31.5 voltage. You have to reduce the input voltage with the help of tripod by tuning the resistor of the buck converter. I have set the battery charging voltage as 14.6 volt. The output voltage of the buck converter is given to that battery. You have to tune the buck converter according to the charging voltage specified in the battery. You can see that I have set the value to 14.6. I think the maximum charging voltage can be 14.9. The output of the buck converter is given to the battery. If the battery take longer time to charge, then you have to set that to maximum value like 14.9. If it take lesser time, you can set to 13.5. If the battery voltage crosses 12.8, and disconnect the battery from the charging circuit. The battery charging voltage is 12.52 and the battery voltage is 12.51, which is more or less same. Since the output of the battery is DC, we have to connect the DC load only. We are connecting on DC bulb and a fan only. I have switched on the bulb. I think this light is enough during power cuts. Though it is not a regular fan, it may give sufficient air. It is also a DC fan. The battery voltage with load and charging is 12.22. There is a drop of 0.3 volt. Now I am switching off the light and we can check battery voltage with fan only. The battery voltage is 12.26. If you are sleeping during night, don't use the light but fan only, so that you can use the fan for long hours. Voltage drop is 0.24 voltage. The transformer rating is 230 volt 12 step-down transformer with current rating of 3 ampere. Since the transformer rating is 3 ampere, the diode rating is also 3 ampere. Pi filter C1 value is 4400 maximum and 2200 minimum with 50 volt maximum. Pi filter C2 value is 1000 microfarad 35 volt 250 volt maximum. You can select the C1 value as 50 volt also. The pi filter inductor value is 10 millihenry. You can find the values of C1, C2 and L value with the help of Google search. If possible, I will publish a video short to calculate C1, C2 and L value for any specification. You select a buck converter voltage range according to the pi filter output. This is only battery charging circuit and needs a battery to work. I am using 12 volt 9Ah battery for this specification. Step up transformer will have a loss of 50% loss for 60% load. Inverter circuit has transistor and switching losses. These losses are avoided. You have circuit diagram also. Take screenshot to start. The power consumption and making of the device is very less. You can buy battery charger and use with the battery, bulb and a fan. If you are not interested in DIY, you always work with a breadboard, not like this. For video purpose, I am showing the circuit separately. Please take screenshot. Please like, comment, subscribe to my YouTube channel. Kannan Karnataka Tech Vlog.